Welcome to the Super Memory for Schools program. My name is Phạm Nguyễn Thúy An. I'm a chemistry teacher in high school for gifted sports and physical education, Ho Chi Minh City. Today, we'll learn together lesson 36 of 10th grade chemistry. In this part, we will learn about the practical significance of the reaction rate. As you know, the reaction rate performs crucial roles in our life, and you can see its application in life every day. The first application is fridges that can help us preserve our food. As we know, the higher the temperature is, the faster the reaction rate happens. Therefore, when we store food in the fridges, we can preserve it for a long time. If we store food in the freezer compartment, the preservation time can last longer. This is the first application of the reaction rate in daily life. The second application is the pressure cookers. As we learned in the previous lesson, when the pressure increases, the reaction rate increases too. Therefore, the pressure cookers can help the reaction process run faster. It means that it will help your cooking process run faster. About the catalyst, we all know that in the fermentation of wine, fruit juice, and yogurt, if we add fermenters to the process, it can happen faster because fermenters are catalysts. To consolidate the knowledge we've learned in the lesson reaction rate, we will do some multiple choice questions. Question 1. When we add the same amount of zinc to a cup containing hydrochloric acid HCl, which form of zinc will make the reaction rate be the highest fastest? A. In small granules. A. In thin plates. B. In strings. D. In powders. Let's solve this question together. As we know, the smaller the size of solids is, the larger the contact surface is. Therefore, to make the reaction rate run faster, we need the largest contact surface, so powder is the correct answer. We will move on to the second question. Compare the reaction rate of these pairs of reactions. Here I have 3 pairs of experiments. In the first pair of the experiment, it is the reaction of powdered iron and HCl solution, 1m at room temperature, and the reaction of powdered iron and HCl solution, 2m at high temperature. We see that in the first reaction, the concentration of HCl solution is 1m with the room temperature. In the second reaction, the concentration of HCl solution is 2m and the reaction happens at high temperature. As you know, when the temperature increases, the reaction rate increases too, and the higher the concentration is, the faster the reaction rate is. Therefore, the reaction rate of reaction B is greater than that of reaction A. Let's move on to the second pair. In the second pair of the experiment, reaction 2A, aluminum reacts with NaOH solution 2m at 50 degrees Celsius. In reaction 2B, the reactants are also aluminum and NaOH solution 2m, but the temperature is at 25 degrees Celsius. As a theory, we learned the higher the temperature is, the faster the reaction rate is. Because the temperature in reaction 2A is 25 degrees Celsius, it is higher than the reaction in 2B. Reaction 2A happens faster than reaction 2B, and we will move on to the last pair of experiments. In reaction 3A, we will heat the gas mixture by SO2 and O2 at 450 degrees Celsius. The reaction is catalyzed by V2O5. In reaction 3B, we will do similarly like the reaction 3A without a catalyst. As we've learned, the catalyst makes the reaction rate run faster. Therefore, the rate of reaction 3A is faster than that of reaction 3B since reaction 3A has catalysts. In conclusion, you should bear in mind these main ideas. The first is the definition of reaction rates and the formula to calculate the average reaction rate. The second is influence factors of the reaction rate, including concentration, temperature, pressure, contact area, and catalyst. The third is the practical application of the reaction rate in our daily life. That's the end of our lesson today. See you in the next lessons of the Super Memory for Schools program.